Hello guys, welcome to my channel. So today I'm making this video to show you a demo of a AI powered SQL agent that I've been working on lately, and I've been working on this project since last 2 to 3 months, and it has come up pretty well. So let me show you what exactly a SQL agent is, okay? But just to give you a high level idea, now with the help of SQL agent, uh, you know, leaders, managers, they don't need to wait for the data insights for their from their business intelligence team or their devs to develop a report. They can get all the business insights from their database on the go just by chatting with the app. Okay, so let's jump right into it. Okay, so this is the login screen, and yeah, if you're new, you can create your account here. You can select a plan basically. So we have four plans like trial, premium, basic, and enterprise. Each plan has its own features. So let me log in with my username and password here. Okay, here you see a basic dashboard screen. Okay, and uh, so we'll go to the chat screen later, but let me talk about first training a model. So here you can choose a training file. So uh, let me just go ahead and choose a training file here. Okay, so basically your training file has to be in CSV format, and you can upload your file here, and then in start training you can just select that file, and you can select the model you want to fine tune. You can give a custom suffix to the model. So once the base model is trained, a new fine tuned model will be created, and this suffix will be in that name, so it is optional anyways, and then you can start the training. And as you start the training, so depending on if you want to go with the local models, like llama 3.1 instruct with 7 billion parameters, or so yeah, you can choose a model of your choice. And right now we are training OpenAI model, and I've already gone through the training process and uh, created a fine-tuned model out of the base model, and this is the fine-tuned model that I've created. And if you want to go through all the training data, what is the stepwise loss that is, and what's the final loss that we have achieved, what was the learning rate multiplier and the epochs and the batch size. So all this information is available here. Okay, so this is my CDW training data.json L file. So it accepts the training data in JSON L files, which is JSON lines, and this is the chat completion format. So uh, this is the training data that I've uploaded. It's around about 1,000 lines. So yeah, okay. And then what you can do is once your model is trained, uh, you can use that model in the chat here. So if you see this training model, uh, I can select that training model here, and I can ask it any question that I want, and it will pull the insights from my database. So right now I'm connected to. So if you go to database config, you can configure your database here. And right now I'm connected to the clinical data warehouse data, which is on my local system. Uh, and how many number of tables and everything, all that database schema information is here. If you want to extract schema for your for other databases, you can do that too. Give me 1 minute here. Okay, and then this is used for this model is used for chatting, so I can just ask it. I've trained it on my database, so I can kind of like just ask basic questions like show me all the patients uh, who are above 30 years old. Uh, and then it will go and, you know, get the SQL query that will be executed on the clinical data warehouse database, which is here. I can use this voice to text functionality here, and I can ask it some questions. So let me ask, show me all the patients who are suffering from hypertension. Okay. So it's thinking, let's see what it gets. Okay. Show me all the patients and their procedures. Okay, it's thinking. Let's see what it gets. Okay. So yeah, here's the information. So it's got me all the patient's information like patient ID, first name, last name, date of birth, and all the procedure codes that they have. So David Anderson, X-ray chest, and all these other patients, colonoscopy, blood draw, showing 10 of 19 results. You can kind of download the results here. Right, you can also download these results to a CSV. All right, moving ahead, let me show you some of the functionalities here. So, it depends on how well you train your model, what's the size of the data set that you train it on. And this is basically a combination of a lot of agents working together, you know, s- yeah. Okay, so if you go to the super admin screen here, we can create different accounts for different clients, and then, you have user management functionality where you can manage the users for that client. You can, create new users, you can edit the existing user, reset the password, and all the basic functionalities that any application has. Here you can do your basic plan management, country, time zone, currency, language, storage config. So basically, all the training documents and everything right now, I'm storing it on local, but I can, move it to the S3 or any GCP bucket, all the rack documents and all the training data sets and everything. Here are the list of the databases that are supported, where, you know, our application can connect to these databases and uh, yeah, and get the data for you. So that's in short the super admin functionality. And then for the account admin functionality, except super admin, all the other options are available. So basically you can do your database config here. You can tell the AI which database to connect to and get that information from. uh, it's normal user management, accounts, payments. Okay. And then there are some important settings in your accounts tab, if you see. So basically, uh, these are AI workflow settings where if you want to share your data for query optimization, just in case if you're using OpenAI model, which is hosted, uh, on the OpenAI server. So you want to share your data with OpenAI, so that it gets insights about your data and the number of retries. So basically, in the background, first time when it returns a SQL query, and if it doesn't execute on your database, then what are the number of retries that you want? Because it's going to send the error message and kind of your table schema to to the model, uh, so that it gets better insight and it can correct that query. So those are a lot of input tokens. So this is like a kind of a cost saving option. How many number of retries do you want to do before it gives up? And yeah, So database config is also important. Obviously, I told you you can configure your databases, and then uh, if you have uh, yeah, if you have more than one database that you want to uh, you know get the data from, so you can select those databases here. But for now, I'm just going with clinical data warehouse, and we have other databases also, but yeah, we're not going with them. And then this is a document store when where user can go ahead and upload their doc used for retrieval augmented generation. Uh, yeah, so I can kind of upload any knowledge base here, which will also be used in the query generation. So once now this is in process, it will get embedded, and it will be stored in a vector database. So uh, yeah, so if you see here, account one documents, one document to collection, and then the MongoDB client initialized. Okay, so if you go to vector stores here, that is where all your embeddings and the metadata is stored, which can be used to augment your prompt uh, to the model. So yeah, that's in short what I have done. Okay, let's ask it something which includes some complexity. So let me see. So let me see, instead of a trained model, if you can just use any other model and how it performs. So show me all the patients and the count of their diagnosis, procedures, allergies. Let's see. So now I'm using GPT-4 model, which is not a fine-tuned model. And let me see, without fine-tuning, how, okay, 400, this model's maximum context is 8,192 tokens. Okay, cool. Okay. So basically what it's trying to say is that I have exceeded the context length of the model. So basically the number of tokens that I'm sending to the model, so I'm sending all this information, all the schema and everything. Maybe it was not able to answer without the schema because it is not a trained model, right? So I'll need to kind of, it doesn't know about my database patterns, my tables and their relationships. So yeah, so this AI agents are working together where uh, first time it would just send a small context, depending on what you have configured here in your keyword crosswalk. So this keyword crosswalk is basically, you can just add a mapping here and you can say that, hey, if my query includes some of these words: diagnosis, illness, problems, disease. So this is the diagnosis table that you have to kind of uh, diagnosis table schema that you have to augment the prompt with, so that the model understands the structure of the diagnosis table. And so yeah, so you have created this mapping. So once this mapping is created, uh, it will try to use that mapping, and it will augment the prompt. And if the model fails to generate a correct SQL and it errors out, then there's a retry mechanism where, while retrying, it will kind of send the full schema basically. Yeah, yeah. So that is what has happened here. So it seems like the uh, GPT-4 has a smaller context window, and context window is the number of input tokens that you can send it, or it can handle at once. Okay, let me select GPT 3.5 Turbo 16K, and let me ask it the same question. Show me all the patients and the count of their diagnosis, procedures, and allergies. Okay. So yeah, this is the SQL query that it constructed and returned this results. Okay, and it shows patient wise what's the total count of their diagnosis, procedures, allergies, everything. Okay, so cool. You can download the CSV, show all. Let me ask it, show me the patient and all the patients who are allergic to penicillin. Okay, this is one problem in the app. It doesn't change the focus when I ask it the question. It remains there and it doesn't shift the focus to the results. Okay, yeah, here we got the results. So John Doe and Robert Johnson are the patients who are allergic to penicillin. I can ask it, show me the patients who have diagnosis of hypertension. You know, this I've already asked. So show me the patients uh, and their observations again. So this is something that I'm yet to fix. Okay, there we go. Okay. All right. So yeah, it's showing results like all the patients and their observation name. So yeah, this is kind of a small POC, but this can really be made, to handle complex queries and yeah, it depends on how well you train it. And yeah, just to show you that I have successfully been able to train the model uh, on on the GPU pod as well. So not necessary that you have to use the OpenAI's proprietary models. You can you know train your own model. So yeah, right. So here, if you see uh, in the models directory, I have this model that I've trained Llama 3.1, 8 billion parameters instruct. Okay. And what happens is when you not train but fine tune, sorry, yeah. So what happens is when you fine tune a model, you will see that something happens. So uh, it will in this adapters folder. If I show you this adapters folder, uh, okay, Acme, that's the client name because we have a client voice directory. And okay, so I have versions, different versions. So let me tell you what I'm trying to show you is that uh, so these are all the uh, you know model fine-tuned delta weights that it has generated. So basically what happens is uh, when you fine-tune a model, okay, the base weights of the model will they're frozen. Okay, so what a model what you can do is there's something called as a LoRa, which is low rank adaptation. Okay, which means that if you see the model weights are, and this basically will generate the delta weights only for the attention head. So, uh, your query key and value weights is something that it will, the delta weights that it will generate. So that, and those delta weights are basically when a model goes through a training process, it learns from your training data. And to train the base model, it is a huge task because it has billions of parameters. Okay, so what it does is it will create a low rank matrix, kind of like a weight. Okay, maybe like, if I think GPT-2 or GPT-3 is, the attention heads, the query key value are in thousands by thousands, like, 70,000 by 70,000 or something. I don't remember top of my head, but yeah. So you can't afford to, uh, just because of your small data set, we cannot afford to change the base weights of the model. So what it does is it creates a low rank matrix, and or a weight, and it will, add those delta weights there. And then while, at inference time, so the activation function now, instead of, uh, suppose you have a, uh, base uh, query weight. So now it becomes the base query weight plus the delta weight. Okay. So, and uh, the input value. So let's see if that is input value is X, and the weight is, your base weight is W. Then it will become X W, X into bracket W plus delta W into, plus bias. So yeah, that is how it works. And it works pretty well if you train it well. So yeah, that is what I wanted to show you all, and I hope you like this. If you have any questions, just put it in the comment section. Okay. So thank you so much for watching this video. Have a good day. Bye.